Hello friends, welcome to the YouTube channel of Chamilativi Institute of Pharmacy Indore. Now today I am with the another basic topic of pharmaceutics, that is pharmaceutical mixing. So let's see the topics that are need to be covered in the session. The topics to be covered are definition, application of mixing, then types of mixtures, mechanisms of mixing, and factors affecting mixing. Now let's see the definition. Mixing is defined as the unit operation that combines two or more components together by agitation, shear or mixers. So when two or more components are mixed together, the final product of mixture contains uniform distribution of both components of mixture. And mixing may also be defined as the process in which two or more than two components in a separate or roughly mixed condition are treated in such a way so that each particle of any one ingredient lies as nearly as possible to the adjacent particles of other ingredients or components. And the example of mixers are planetary mixers, blenders, propellers, etc. Now let's see the application of mixing. First is to get true solution after mixing two miscible liquids. So when we mix two miscible liquids, it should give a true solution. Then second application is it will give the uniformity of composition between the mixed ingredients. It will enhance the physical or chemical reactions to improve dissolution and diffusion of mixture. To produce suspension when an insoluble solid is mixed with a vehicle. So when a insoluble solid is mixed with a vehicle, then it should give a proper suspension. Another application of mixing is to produce emulsion when two immiscible liquids are mixed together with emulsifying agent. To produce a solution after mixing a solid with liquid. To produce semi-solid products like ointments, suppository after mixing solid or liquid with semi-solid base. And in manufacturing of tablets and capsules to get proper mixture of solid powders. So these are the applications of mixing. Now the next topic is the types of mixtures. Mixtures may be classified as positive mixtures, negative mixtures, and neutral mixtures. So these are the three types of mixtures. Now first let's see the positive mixture. Now when two or more than two gases or miscible liquids are mixed together by means of diffusion process, then it is known as positive mixtures, and in this no energy is required. So when we mix two miscible liquids by diffusion process, the type of mixture is called the positive mixture, and here energy is not required. So here you can see that A and B liquids are mixed, which are miscible liquids, and this is the instrument which is used to form positive mixture. Generally they are paddle mixtures or homogenizers. They are used for positive mixtures. Now the next type of mixture is negative mixture. When insoluble solids are mixed with the vehicle to form a suspension, or two immiscible liquids are mixed to form an emulsion, then it will give the negative mixtures. And it required a higher degree of mixing with external force. So to form a negative mixture, external force is required. For example, when water and oil are mixed together, then it will form an emulsion, and both are the immiscible liquids. So for the emulsion or suspension, in the industry, bulk emulsion mixing unit are used for negative mixtures, that is emulsion or suspension. Now the third type of mixture is neutral mixtures. The paste, ointments and mixed powders. These are the example of neutral mixtures. And they are static in behavior, which means that their form cannot be changed. They are fixed and stable. And such products, they do not have any tendency to mix spontaneously, but once mixed, they do not separate out easily. So, in the formation of paste ointments, uh, when we mix ingredients together, they cannot be separated out easily. So, these are called the neutral mixtures. These are the ointment mixture which are used in the industry. Now the next topic is the mechanism of mixing. So there are three mechanisms. First is the convective mixing. So it includes the transfer of group of particles in a bulk takes place from one part of powder bed to another. So in convective mixing, transfer of particles taken place in bulk form from one part of powder bed to another. And this type of mixing is also known as macro mixing. Another type of mixing is shear mixing. So in shear mixing, shear forces are created within the mass of material by using agitator arm or a blast of air. So by creating the shear forces between the particles, shear mixing will take place. The third mechanism of mixing is diffusive mixing. So here the materials are tilted so that the gravitational force causes the upper layer to slip and the diffusion of individual particles takes place over newly developed surfaces. So in diffusion mixing, what happens when materials are tilted? Then due to gravitational force, the upper layer will slip to the over newly developed surfaces. So this is called the diffusive mixing, and it is also known as micro mixing. Now let's see the factors that affect the mixing. First is the nature of product, then particle size, particle shape, particle charge, density, then volume, flow properties in case of powders, mixing time, surface area, and the mixing mechanism. So these are the factors that affect the mixing. Thank you guys. So in the today's session we discussed definition of mixing, then its applications, then various types of mixtures, then mechanism of mixing, and various factors that affects the mixing. Thank you.